Hello, everyone. Come on in. We're a little late. It looks like we got 12 of us in here. So since I started late anyways, I guess I should go ahead and get started. I want to tell you guys, like I did last time, we are asking you to send a chat of your first and last name so I'll know you're here. You can do that right now. I don't really care whether you like split after. I mean, I care. I don't want you doing that because that means less likely that you're going to be able to learn as easily you were actually in the class, but that's on you. So I'm completely cool with you doing it as soon as you get in. If I find out later that you're leaving, there's no ramifications. I don't give you extra points for being here, that sort of thing, but you are harming yourself. So just feel free to do that now. If you don't remember to do it, then make sure you do it before the class is over. That way I can always have whether or not you've been here. I'm going to also open up the board right now to anybody have any questions regarding homework or anything else. So the syllabus, of course, has been posted. Hopefully, y'all have seen that. The homework assignments, not only chapter one homework and chapter one conceptual, but also intro to mastering and physics primer. All of those are available, and the chapter one stuff is due by Sunday at 11:59 p.m. I think you got a couple more days for the intro to mastering and the physics primer. And those last two actually do count as extra credit, but I promise you it would be much better if you do it than if you don't. So does anyone have any questions on the syllabus, on any homework problems you ran into, on any, introduction to mastering or physics primer questions you might have?
The links I've been trying to use from Canvas, that link to, I guess, Pearson,
Uh-huh.
it's just giving me errors. That's what I text you about.
Yeah,
Yeah,
you're the one that texted me.
yeah,
I didn't follow up later that night, one, because I had a class and then I had some people show up for office hours and then it ran a little longer. And not only that, I noticed I was having problems. So I was hoping it might have been a case of Pearson having some kind of bandwidth issues. That's why I didn't. So I needed to find out today whether or not you were still having problems. And you say you still are?
yeah, because it's saying, let's see, it says that it's like on the instructor side. It says now that there is some tool that has to be used to pair LMS courses. It's no longer available for something, and it says you and your students can continue to access my lab and mastering from existing this, and then it says see instructor help.
Okay. I am looking right now to see what it does when I connect. It looks like everything's connecting from my side. I can also, let me double check my courses. There's this little thing when I look at my courses, it should have a little chain link next to it if it's connected with Canvas. And if that's not there, I know it's not. So we're 241N02B, and that one does show that we have a link. So it is linked. I just also pulled open mine and it seems to have brought me to chapter one conceptual. Now, are you specifically going into Canvas and then clicking on mastering?
Yeah, if I click access Pearson, it does it. If I go into modules and click any of the chapters,
Hmm.
chapter one homework, chapter one conceptual, it does the same thing.
Okay. Now I notice, for instance, when I click access Pearson, the screen that I'm in doesn't show anything but a couple of books. After I press the button access Pearson, it opens up a whole new tab. So one thing you want to make sure that you allow Pearson to open up new tabs and new windows.
Yeah, I did that. Yeah, okay, so now it shows the open Pearson, but it still wants me to register, saying student links and all that. But if I go to the homework and click that, I'm still just getting an error.
Okay.
Uh,
The good news is when you said it still wants you to register, that is probably what you need.
well,
You're
I
allowed to
have,
register right now for free, but you say you did do that?
yeah, I've bought it. I've used Pearson in other classes.
Okay, and you've actually logged in and used your username and password for that Pearson
Yeah,
account?
and it brings up and wants me to register your course, but it said I needed a course number or something.
Ah,
Uh,
okay. So what happened when you did that is it took you to the mastering website without being inside of Canvas. If I were to, for instance, give you the actual course ID, and you type that in, you would no longer be able to access the course through Canvas, and I'd never be able to see your grade. So you definitely don't want to do that way. Uh, what is supposed to happen? Well, let me ask this because other students should have the same problem if it's something wrong with Pearson. So, do any of my students have a similar problem? Anybody else having the problem that Dylan's having?
I had it earlier, but it's working at this moment.
It is okay. That's good. Sometimes, Dylan, all it takes is to empty your cache of your browser. So you might try that. And what browser are you using? Tell me
I've
the Safari, for
been
instance.
trying. I've tried it on two different computers.
Okay.
I used it on my laptop, and I'm on my desktop now, and it's still the same issue.
They're not both Macs, are they?
Neither,
Okay, good.
not at all.
Because Safari is notoriously bad, and hopefully you're not using Microsoft's
No, I'm
whatever.
using Chrome.
Okay, good. Chrome. Yeah, Chrome. At one time, I think I was told Firefox works better, but both Chrome and Firefox is always works good. So I don't think that's your problem. I would definitely contact Pearson for
I
this.
I
Keep me
think
in the loop because I can give you extensions for this problem that isn't yours.
well, I think just I tried something different and went in a different way, and this time it finally linked it. Before I've been clicking where it says open my lab and mastering through your link,
Right?
and it wouldn't. It would keep wanting me to register and all this stuff, even though I had already registered. But this time I clicked it and it finally went through,
Awesome.
and it's showing, okay, now it's showing the text and all that stuff.
Cool. And you can see homework one and all that good stuff.
Let me see if I can access that through the modules and stuff now.
Down, you should see something that says all assignments. You can click on there or
Yeah,
something.
if I go to the, so if I click the Access Pearson, and then I follow the link where it says open my lab and mastering, and then that opens Pearson. It opens your course. It shows me everything right there, but I still can't. If I go to like your modules and click homework one, it still does not. It still gives me the same error. But if I
Okay.
guess if I launch Pearson the first way, I can just find the assignments through there as opposed to just clicking um, where you have it listed under homework or under modules.
Gotcha. Okay. Well, that sounds like it's doing okay. I would say right now, I mean, you can keep trying like, once a week or something like that to try to click on the link in my individual modules for a particular homework assignment. Uh,
Mhm.
that might
I'm having that
eventually start
same
working.
problem too.
You did too? Okay. I was gonna
If
say
you
that
click on
might
the link
eventually
through the module,
fix.
then the error pops up. But if you click on the Access Pearson and sign in that way, you can access. If I access to that way, do you still see the grades?
Yes, yes, that shouldn't be a problem as long as you go through Access Pearson from Canvas.
Okay.
So yeah, that shouldn't be a problem. In fact, I'm going to check right now just to make sure. What was your name is Jennifer, right? I was just double checking so I can check the grade book. So it looks like I do have Jennifer in my grade book. I do not have Dylan in my grade book yet though. So
Yeah, I
uh
haven't done anything yet because I haven't been able to. This is the first time I've been able to get in it.
Gotcha. Okay, Dylan, if Sunday you're unable to get the stuff done by then, just drop me a text message. Send it a text message. Don't bother sending an email. And I'll go ahead and give you an extension because obviously you've had a couple of days of problem with this, and that's not a problem. And to be honest with you, you know what? What the heck? The only reason I'm inclined not to push the due date back for this first set of homework is I want you guys to get in the swing of being used to having a homework due at 11:59 on Sunday.
Mhm.
Uh, but in light of this and in light of the, sort of fairness, what I'm going to do is go ahead and set the due date back for uh for this first set of assignments. I'm going to set the homework back to Wednesday.
Okay.
And that's just for homework 1 and chapter 1 conceptual. So let me
Okay.
do that real quick. And then that way that covers you, but also, no one feels, slightly bad that someone else gets an advantage, which obviously you have a good reason to get an advantage. So I'm pushing this. You guys meet me on Mondays and Wednesdays. So what I'll do is I'll push it back to, yeah, I'm just going to do Wednesday, even though that's kind of abnormal. So it's now due on 9/4 at 11:59 p.m. for homework, chapter 1 homework, and for chapter 1 conceptual. And the MyLab and mastering, or introduction to mastering, is due on 9/11, and physics primer is due on 9/11 as well.
Okay.
Okay. Anyone else have any problems? Thanks for that clarification too, Jennifer. That helped.
Professor, on the Canvas page, I noticed like we go through Pearson, and then there's also a link on there for purchase course materials. Is the only stuff that we're purchasing just on Pearson?
So purchase course materials takes you to our book publisher, which is Follett, who's contracting through Barnes and Noble. So you can buy the stuff there, and everything is available there, but you can also buy them at the Pearson site. So either one you want's fine.
Just following that link and okay.
Yeah, I haven't. In fact, when I do look at it in the purchase course materials, it sometimes looks quite a bit different than what you see. So I
Yeah.
haven't even tested it, but I'm going there now just to see. And yeah, it doesn't just jump out and say, "Hey, your course materials, blah." But up at the top, there is enter your search details, which is product title, ISBN, keyword. So you can use that ISBN that's in your syllabus, for instance, and that should help you. Let's see if I can just do a search for PHY 241.
Yeah, I believe I had found like the textbook when
Uh,
searching. I was just curious if like paying for the Pearson version, if that included the textbook or if that was just the My Mastering Physics Lab. I don't know if they were both, because I've
gotcha.
noticed like, previous classes when I paid for something on Pearson, it included like an e-text, but I wasn't sure if that was the case here. I just didn't want to double pay for something if
Yeah.
the case.
Yeah.
Um,
So it has, for instance, this thing that I see for $187.50. I'm clicking on that to make sure that, man, they don't even give you much of a description, do they? Summary.
yeah,
I went to the one through Barnes and Nobles, and I think it was like 180 something, and it gives you an access code to put in through Pearson, and it gives you the e-text and the work.
The access to it, right? Yeah, so
okay.
that's what I was hoping. It at least gave you the e-text, and it should at costing 187.50. I'm still very upset that it costs 187.50. I think a more reasonable price would have been around $100 since you're not getting a print copy of the book. But
Yeah. And I
uh,
mean, yeah, and that's just like I was trying to figure it out because on the if I follow the Pearson link straight from your website, there's the option for like $150 and then there's one for like 85 and it says like mastering physics with Pearson e-text for 85, but like Dylan was saying, I just saw like two different prices and I was like I didn't want to like get the
right.
wrong thing.
You might call them to find out for sure. That $87 one, if you only had to take one semester, that might be worthwhile because it might even be the $80 one is for like 18 weeks or something.
Yeah, yep.
So that would be a bad thing if you need to take 2 semesters, or if perhaps you failed the first semester, you'd have to buy it again the next semester. But if you only have to take one semester, I'd say go for it, and that can save you some money. Uh,
Yeah. Okay, cool. I'll look at that. And then the next question I had about the syllabus, like I click on the syllabus link on Canvas. Is
uh,
there like a Word document with your syllabus that I'm looking for or
it
no?
should be like right now. I just put it. I thought I put it up right here as a PDF.
Yeah, I was wondering the same thing because it just shows all our assignments.
yeah, like I see the chapter 1 conceptual, but that's that and everything else, but I didn't see
Oh,
any.
yeah. So the little syllabus link at the far left, I don't use that because I haven't had very much success with it. I usually put it in, if you click on either home or modules, I usually
Okay.
put it in a module called helpful links and documents. And I'm looking at it right now. That's an old one, so that's not good at all. Yeah, I don't know why it's not up here. Let me do that real quick as well then. Uh, it's weird. I
Cool.
just did it like just before class started. That's part of the reason I came in so late, but I do not see it on here anywhere. Okay, so what I'm going to do, where you see it says helpful documents and links, I'm going to import that right into there, and you should see it appear pretty soon. And I'm going to 241 N02B. Ah, I see. I'm going to go ahead and put it up in Word form for right now, and I'll make a PDF and do that a little later. All right,
Okay.
right now it's at the very bottom, but I'm getting ready to move it to the very top because that's the first thing you should be able to access. So you should see PHY 241 N02B syllabus, and that'll be it.
Yeah, I see it now.
Okay.
Okay, yeah, I see it there too. Cool.
Sorry about that delay on that, everybody. It
No,
was really
no,
good for me to switch to what I was doing, but I lost a bunch of stuff, so it took a little while to rebuild.
no worries. And sorry, I had joined in late. What did you say the names was like an attendance thing? Is that what all the
Yeah, if you just
Okay.
chat me your first and last name, that's how I'll keep attendance.
Okay,
So that'd be great.
cool.
Anybody else that came in late, please do that as well. It doesn't matter what time. You can do it as soon as you get in. You can do it just before you leave. I would say do it as soon as you get in. That way, it'll already be there. Again, I wouldn't use that as an opportunity to just leave early, but if you need to, it's okay. I mean, you guys are college students. Y'all know what you're capable of and what you're not. So I'm cool with that. I'm not going to hold any grudges or be upset with you or anything. Does anybody have any other questions? I know I spent a lot of time on that, but that's certainly fine.
I did have one other question.
Go ahead now,
It's
Dylan.
related to the lab. I don't have
Mhm.
you for lab. I have, I guess, Professor McCabe.
Mhm.
And I got an email saying that there isn't a lab this week. It says you're not required to come. So
Okay.
does that mean like you could still go for some reason? The way it's
Uh,
worded, it almost makes it seem like you could still go, but you don't have to.
yeah, that's the passive voice that us science majors learn to speak in. So I apologize for that, but if they said you don't have to go, that means yeah, don't bother because the instructor might not even be there.
Okay.
Uh, that being said, when you do show up, if there's an instructor around, sometimes they can help you with stuff, that sort of thing. But yeah, if they tell you it's not required, it's not required. And I do know for a fact that we hired a new person to help us teach labs in Virginia Beach. And that person had some trouble getting access to Canvas and SIS and all that. So that's why that particular person's lab courses had to be canceled this week.
That's what I was wondering because I was like, I don't recognize this name. I thought I had signed up for somebody else. And
Yeah, it's a new person that I think he literally might have just finished his PhD, and but he comes with good recommendations, and the fact that he has a PhD is really good because we really only required to have a bachelor's to teach lab, so
okay.
should be super prepared. Uh, and also the way it works is his schedule is going to be behind ours, uh, or he's going to have to completely axe that first lab, which I can't imagine he's going to do. So that might make it virtually impossible for you to ever make up a lab the whole semester. But each week, if you find out you have to miss something, go ahead and ask your instructor, and they might be able to say, no, you can attend Mr. Younger's or Mrs. Raskovich's class or something like that, and that'll let you. But generally speaking, we can't make up labs or anything. So I just let
Okay.
you. Okay.
Okay. Thank you.
You're welcome. All right. So that looks to me like I've gotten everybody's questions answered. So make sure you guys try to get your homework done. Now you have until Wednesday at 11:59 p.m. But just remember every week, Sunday at 11:59 p.m., you should plan on there being homework due. And in fact, the way my schedule works out, you should have 2 homework assignments and possibly an online test all due at 11:59 on Sunday. So you might want to set like an alarm for like, I don't know, Saturday morning, and just say, hey, probably have homework due 11:59 on Sunday. So if you get an alarm on Saturday morning, you'll have a couple days to do it. But ideally, the best way to learn physics is to do a little bit of physics every day. So even though our class only meets Mondays and Wednesdays, I'd say make sure you do at least one of your homework problems on Monday, at least one on Tuesday, at least one on Wednesday, at least one on Thursday, at least one on Friday, at least one on Saturday, at least one on Sunday. By and large, that helps your grade a lot. Okay. If you don't, I'm never going to know. I'm just telling you that's what we've learned. Just like with taking music lessons and that sort of thing. If you actually play daily, you do better. Same thing with physics. If you think about it at least a little bit every day, you're probably going to do a little better. As opposed to, oh crap, this is due tonight. Let me start it at 6 p.m. on Sunday. Okay. Any
I have one more question.
Go ahead.
Like with the practice tests,
Mhm.
can you open some of those up?
Yes, in fact, I'm probably going to open up practice test 1. I might even just do it tonight. I normally do it within the first week because it's normally a little bit of time before that. But yeah, I can go ahead and do that. The thing is, when I copy those practice tests into the course as well as the chapter practices, sometimes it puts them in there and they work great. Other times it like puts them in there and like, I don't know where the questions came from, so there's no questions in it. So until I go through the process and check every one, I can't do much. But I'll definitely be trying to set everything up at least by Friday. That's my day that I don't have any quote unquote teaching. So Friday's the day that I'll try to grade labs, look up whether my practice tests are working and all that. So they'll definitely be up by Friday. They might be up tonight, at least the first one. That sound good to everyone?
Sounds good.
All right,
Yes,
I'm gonna
thank you.
go ahead. You're welcome. I'm gonna go ahead and set up my good notes system. I think that's what I'm using. And today is the 28th. I have that. Okay. All right. Now I'm going to attempt to share my screen with you so we can start talking about what I think is most important about chapter 1. I did provide in week 1, if you look at it, you'll see week 1's module. It has, it has Canvas will not open a YouTube link. That is sort of a funny inside joke that I made basically with myself, just because if you click on it, you can't look at it because it's literally got a problem with opening a link in Canvas. What I want to tell you is when you click on one of those links, it's going to say can't load and it shows that unhappy computer face. If you look at the top of the bar that is the window for where that little unhappy computer face is, right next to the title for that link is a little box with an arrow in it. If you click that, that'll actually take you to creating a new tab and take you to the YouTube video. So make sure you do that if you have any problems with the YouTube video. But the more important thing that I was pointing at is you'll see there's a link to scientific process systems of units and their conversions. And then you'll see another one, unit and dimensional analysis. And then you'll see the other ones are sort of repeats of that same stuff. But those the second and third video in the optional video section of week 1, I highly recommend you watch those. And then the rest of them you should watch as examples of how to solve problems, at least towards the bottom. If you'll notice, for instance, the fourth one down says sig figs, psi notation, and units and dimensional analysis. That's just somewhat a repeat of the 2 that I just said you should watch. And the one after that's also a repeat. The one after that says unit conversion multiplicative. That's just a description about how you convert units. So that's a good thing to watch. Convert Fahrenheit to Celsius. That's another type of example that in principle you need to know how to do. Dimensional analysis and relative velocity. That's another section, but you can tell that came from like 2023. But the ones after that are basically just problems that have that I've worked out on YouTube for you. So check those out. I would also say, depending on what your lab instructor uses, if you look under lab accoutrements, there's a link to a video that says sig figs and when they fail. That's a good video to watch to just teach you why we don't explicitly use sig figs. And then after that is a PDF document where I give you basically a set of definitions and rules about working with sig figs. Uh, at least show that to your lab instructor before you use it, just because they might use a slightly different definition of sig figs. If not, that's a perfectly good one. And I've never found a version of sig figs that's not consistent with that. So I doubt it's ever going to cause any problems. But if you're worried about it, definitely ask them. What I will tell you is that when you do sig figs, uh, the way I do it is I define what the most significant digit is, I define what the least significant digit is, and then I tell you that everything between the least significant digit and the most significant digit, including the least significant digit and the most significant digit, are sig figs. If you go through that process with the number 5000, then that sig fig set of rules will tell you that that number has one sig fig. Whereas if I wrote 5000 dot, meaning a decimal, then that would have four sig figs. That's the way my sig fig rules work. And I've got to warn you this way, so make sure y'all are paying attention here. Again, if you write 5000 down and try my sig fig rules, you will find that that has one sig fig. And if you do it with 5000 decimal, you will find that that has four sig figs. In your practice tests, as well as in maybe your first test, maybe your second test, definitely one of those two, maybe also in your midterm, maybe also in your final, there's going to be a question where it has a number like 5000 and it says, how many sig figs does this have? Those questions were written by the textbook author, Giancoli. And his answer to that question, if you read the book, is that it's ambiguous or undetermined. Okay. So that's the answer you want to put when you run into that question on any test. 5000 without a decimal has an ambiguous or indeterminate number of sig figs, at least for those test questions. Okay. So just keep that in mind so you don't lose free points. I'm warning you right now. Okay. All right, so let's get started on this. Let me share the screen and feel free to ask me questions as we go. You can do the little hand raising thing that I think that's, oh, that's not what I want. Sorry. You can do the little hand raising thing that, oh, my screen's entirely different. That's the problem. Let's kill this. You can do the hand raising thing that comes with Zoom, and I'll see the little hand raising thing in my little window off to the right. So that'll get my attention. Or you can just, speak out. That'll be acceptable. Don't worry. I'll if you're talking over me, I'll probably finish my thought or finish my sentence and then answer your question. So let me try to share again and see if it gives me better options. This is weird. It appears not to be giving me notes, whiteboard, Dropbox. Okay. Oh, there it is. Okay. They just changed the design of Zoom and I hadn't seen it till now. Okay. So everybody should be seeing my tablet now. I don't know why I'm seeing it this way because that's not supposed to be the case. Oh, great. So it went away. That was helpful. That's screen mirroring. Maybe that's not what I want. Okay, that's not what I want either. not there either. Picture in picture, I don't want that. Let's say I'm gonna hit escape again with this one, stop share. That didn't work either. Let me try another version. Ah, okay, now I see. They moved yet another box too. Ah, there you go. Excellent. There you go. So now y'all can see this. So the first thing I'm going to do is give you my mnemonic, which is goofy. Okay. I warn you ahead of time that I am chronically, as a grown man, I am chronically stuck in middle school. Okay. So all of my jokes are like daddy jokes, you know, about poop and pee and stuff like that. And other goofy things like cartoons, Despicable Me, The Simpsons, that sort of thing. So when I make up mnemonics, they often come up with something goofy or something that a middle school kid would come up with. So I apologize in advance. Feel free to make up your own mnemonic. But here's the mnemonic that I've come up with the SI prefixes. What I do is I say the dot dot great dot dot monarch dot dot king Henry died by drinking chocolate milk dot dot under, notice that's not a U, that's the Greek letter mu, under dot dot numerous dot dot, and of course you can probably imagine what the P is, but I use the world's oldest profession. Okay, so again, it's a little tawdry or sordid or whatever, so I apologize for that. But make up your own, that's fine. The key thing is you should probably have some kind of mnemonic so that you can remember these prefixes. Now that you have them, what I want to do is say, hey, this is the System International, which you probably know of as the metric system, but I'll also tell you that in the physics community and the chemistry community, we call that the MKS system of units, because it turns out almost all your units can be expressed in terms of the units for length, the units for mass, and the unit for time. And the unit for length is the M for meter, the unit for length is the K or kilogram, and the unit for time is the second. So when we say MKS, we mean meters, kilograms, seconds. That is different from something not unlike the metric system, which was called the CGS system, in which case you use centimeters, grams, and seconds. Now, with that in mind, the whole reason why we did this after Napoleon basically took over France, and remember, you know, Thomas Jefferson, for instance, was literally there at the time. He was the planet plenipotentiary ambassador to France at the time when the French Revolution occurred. So he literally saw the poor people coming in and beheading wealthy people and royalty and stuff like that. He was there, he experienced all that, but it was all about, you know, a spreading of all the wealth of the nation was basically all around the top 1%. And when Napoleon got in there, that could have been all bad, but he actually did some good things. And one of the good things he did was he called a convention to make basically what we now know of as the SI, the System International, which is why it's said like that, because it's in French as opposed to English. But in so doing, we made a rational set of units based on what we had learned from the Renaissance and the Enlightenment, not unlike how we made America after the Renaissance and the Enlightenment. So before that, you had weird things like 1 gallon has 4 quarts, 1 quart has 2 pints, 1 pint has 16 ounces, or 1 pint has 2 cups, or 1 cup has 8 ounces. See how it's like a random number for every conversion. And that's basically due to historic factors. So history dictated that, hey, we needed something smaller than a quart. So someone invented the pint. Or, hey, somebody said we need something bigger than the pint. So they invited the quart. They invented the quart. That's how stuff happened. And it came with numbers that weren't necessarily rational. In other words, when you look back in time, it doesn't look like they had any plan for what stuff was going to be. And they didn't, right? Because they were making it up as they go. So what they did with this is they decided to make it more rational. So each of these base units, which is what goes in here, we call this the base. That's why when I said the great monarch King Henry died by, the by is for base, drinking was for deci, chocolate was for centi, and milk was for milli. Okay. When they did that, they made each of these bases or these dots a factor of 10 different from the thing to the next to it. So for instance, when I say deca, which is what that DA corresponds to, that is 10 to the 1 of the base unit. The hecto is 10 to the 2, and the kilo is 10 to the 3. Of course, then you got 10 to the 4th, which is represented by the dot, 10 to the 5th, which is represented by the dot, and then 10 to the 6th. And then dot, which would be 10 to the 7th, dot, which would be 10 to the 8th, and then 10 to the 9th would be giga, which is the way they pronounce it in Back to the Future. I call it giga, like you're gigging frogs, whereas they called it jigga, like you're jiggling. Okay. And then 10 to the 10th is a dot, 10 to the 11th is a dot, but 10 to the 12th is tera. So tera, giga, mega, kilo, hecto, deca, then the base unit. And the base unit was decided upon based on what you're measuring. So for instance, if you're measuring mass, you find a unit of mass that doesn't have a prefix on it, and that's what we mean by the base. So it could be, for instance, a gram. And that is what it is for mass. It could be the meter, which is what it is for length. It could be the second, which is what it is for time. It could be the Kelvin for what it is for temperature. It could also be the degree Celsius for what it is temperature. It could also be the mole, which you know from chemistry, and various other quantities. We're going to learn throughout the semester that you can have units of like, well, maybe not this semester because this is 241, but next semester we'll learn about the coulomb and the amp and the volt and that sort of stuff. And a lot of those can be made up in terms of things we already have. But if I continue now, we're going to go from the bases, and now I'm going to handle the prefixes that are to the right. So this one's going to be 10 to the, oops, let me write it in the original color. This deci is going to be 10 to the -1. The centi is going to be 10 to the -2. And the milli is going to be 10 to the -3. The micro, 10 to the -6. The nano, 10 to the -9. Oops. And the pico is going to be 10 to the -12. Okay. So there's a couple ways you can use this. And if you were taking, for instance, a biology class, I do know for a fact that biology is getting more and more mathematically intensive as time goes by. For instance, my daughter contacted a well-respected, world-renowned neurologist that teaches at MIT. She basically discovered a part of the brain. And of course, if you do something really friggin' awesome, then MIT will just hire you, or Stanford will hire you, or UC Berkeley will hire you. And that's what happened to her. And my daughter's interested in neuroscience. So she contacted her and asked her for some advice. And the woman was kind enough to write back. And by the way, you can check out that Intro to Neurology at the MIT. And that's how I discovered her. I basically watched the whole course. It was really great. But she contacted her and told her, if you want to major in neurology or neuroscience, you need to learn how to do computer programming. So that just gives you an idea where they're headed. Now, the reason why I brought that up is I want you to know that in biology, you don't usually use too much math. So I would introduce this if I were a biology teacher, especially like in high school. And that is a quick and dirty way to convert units. Let me show you what I mean. Let's say we have a number 0 point. Notice how I'm going to pod my repeating numbers in pods of 3. I recommend and require you to do that in all your handwritten numbers. If they have a bunch of digits, I want you to put them in pods of 3 so it's easy to keep up with, especially if there's some repeats like 1 1 1 1 or 0 0 0 0. So what I'm going to do is I'm going to say 0 0 0 0 0 0 0 0 0 0 0 1 2, 3, 4. And I'm going to say this is tera meters. And what I'd like you to do is convert this to, let's say, nanometers. Okay. So what I mean by this being a quick and dirty way to convert units, this is not the way you want to do it in the physics realm, specifically because it takes too much time and you got to be able to do this probably 15 times on a given test. But what we do is we basically start off with the unit we have. So that means I'm going to start right here with the tera. And now we count the moves. Notice I'm saying count the moves, not the endpoints. So I'm going to say I have to move 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice how I'm hitting the dots. 10, 11, 12, 13, 14, 15, 16, 17, 18. So I'll just put an 18 there. 19, whoa. 19, 20, 21, 22. Oops, no, that's as far as I need to go. So 21. And notice I went from left to right. Okay, so what that means is I need to take this and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now I'm going to say 1, 2, actually, let's run it back here. I'm on 15 now. So I'm going to say 1, 2, 3, 4, and that's 15, 16, 17, 18, 19, 20, 21. Okay, so I'm just going to put zeros in here. And now I can write nanometers after it. So that literally is the conversion. In fact, you might call this number, just to refresh ourselves on what sig figs and scientific notation tells us, this number right here is technically 1.234 times 10 to the negative. That was 15. This is 14. This is 13. So I'm going to say times 10 to the negative 13 terameters. And this converts to 1.234 times 10 to the, in this case, it's going to be positive, and I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th nanometers. Okay, so that one tells you how to use this mnemonic to directly calculate a conversion from one end of the prefixes to the other end. And they go further, by the way. In fact, if you do a Google search for CIA fact book, you will find that that is the most awesome thing to have on your computer. It tells you the areas and square miles and square meters of nations, the languages they speak. It tells you, you know, what a number is that has 23 decimal places or 23, I should say, whole number places, that kind of thing. It tells you all that kind of stuff. It tells you prefixes. It's just packed full of information. So you can check that out. Now, this is not an efficient way to convert units, but if you were in a biology class in high school, you only have to do maybe one conversion every now and again. So it's perfectly reasonable. But by me writing those powers of 10, there's a way that I can actually make use of it. So now I'm going to teach you how to convert multiplicative units. Okay, so one way you can think of multiplicative units is uh, when I say something like $5, you might wonder to yourself, is there any kind of mathematical operation going on between the 5 and the dollar? It turns out there is, because a dollar is a multiplicative unit. And in fact, what $5 means is 5 times a variable called dollars. Numbers with units are what we call denominate numbers, just like a $1 bill is a certain denomination of American currency. A $5 bill is another denomination. So numbers with units are called denominate numbers. And when they're written like that, they're often multiplicative, meaning, like, for instance, if I say 5 meters, I mean 5 times the symbol M for meter. And the reason why you have to think about it that way is because if it was addition, then you're adding 5, a pure number, to a meter, which is not a number and in fact has a unit. And you can't add or subtract quantities that have different units. You've probably heard the phrase, it's like apples and oranges. You can't add apples to oranges. That's sort of the same thing. Now, the units that are multiplicative are stuff like kilograms and grams and seconds and meters and hours and that kind of stuff. It's actually a little easier to tell you which units aren't multiplicative. So has anybody heard of the unit called a decibel? So a decibel, you probably know of it as what hurts your ears at a concert, because basically once you get around 100 to 120 decibels, you're getting damage to your ears, okay? That is true. If anybody ever worked for Cox Cable, Time Warner Cable, Dish Network, or DirecTV, then they also know, or any major electronics company, then they also know that the decibel is another unit that they use. And in fact, what it is a decibel. And remember, that's what the 10 to the negative 1 prefix is deci. 10 to the negative 2 is centi, 10 to the negative 3 is milli. So that's deci. So it means 1/10 of a bell is what decibel means. Well, what is a bell? A bell is a logarithm of a energy per square meter divided by a very specific energy per square meter that you can look up in chapter 16 if you want to. Okay. So if you need to convert those units, you can obviously change it easy as a multiplicative constant from decibels to centibels to millibels. But if you want to convert it from bells to watts per square meter, you have to do a logarithm and all that kind of stuff. So that's not a unit that can be converted multiplicatively. That's not a multiplicative unit. So converting decibels to watts per square meter is not multiplicative. Converting, can anybody think of another one just off the top of your head, a kind of unit that's not just, multiply by a number to change what the unit is? You'll know it when I say it. It's too open of a question, so it's probably not the best question for a teacher to ask. But there's a formula for converting between Celsius and Fahrenheit. It's like 5/9 times the temperature in Fahrenheit minus 32 or something weird like that. That's actually a linear expression. So non-multiplicative units includes this degree Celsius. When you try to convert it to degrees Fahrenheit, you can't do that by just multiplying by a number. You actually have to use a formula. Can anybody think of another one now?
Would Kelvin be like the same?
Exactly. Yeah, that's the one I was hoping for. But like I said, we don't know that many, so I won't sure y'all get that. But yeah, if you need to convert between Kelvin and Celsius, you take your Celsius and add 273.15 to it, and that gives you Kelvin. So that's non-multiplicative as well. So unless you're using those types of multiplicative things, which those types of non-multiplicative things, then the way I'm going to teach you works fine. Remember, a decibel can be easily converted to a centibel or a megabel or a microbel or a terabel, but it can't be converted to watts per square meter multiplicatively. So that's why I said it's not multiplicative. Okay. So all the other ones essentially are multiplicative. So the trick with multiplicative units is that you're supposed to multiply the number you have that you wish to change the units in by a number. But of course, if you multiply a number by any number other than 1, you change its value. So the trick is you want to multiply it by 1. And then all it takes is to realize there's a bunch of different ways you can write 1. For instance, 1 can be written like that. It can be written like this. It can also be written by 1 over 1. But it can also be written by 7 over 7. Or I can get a little crazier and say it's going to be pi over pi, and that's 1 as well. So you're seeing at this point, if the quantity in the numerator, which is the top, is equal to the quantity in the denominator, which is the bottom, then it's also 1. So we can get even more abstract by saying 1 foot is equal to 12 inches. But we could also say 12 inches is equal to 1 foot. Or if you don't like that way of indicating units, you could say 1 foot is equal to 12 inches, or 12 inches is 1 foot. So really all you need is what I call an equivalent statement. If you say this unit times some number is equal to this other unit times some number, then you have an equivalent statement. So I could use this mnemonic that I have above, for instance, to say that, notice I'm going to take the symbol on the left. So if I'm going to convert, let's say, from terameters to meters, then what I write down is the unit that's on the left. So that would be the 1 terameter. And now I write down the power that's associated with a terameter, which would be 10 to the 12th. And now I write the base unit. So that's an equivalent statement. Now that would get me from tera to grams, but it doesn't get me from tera all the way to nano. It takes a little bit of work, and I'm not going to necessarily show you that way, but I bet you could figure it out if you wanted. What I'm going to advise you to do is always convert from the left-hand side to the base and then to the right-hand side, or from the right-hand side to the base, then to the left-hand side. So let me show you how to do the right-hand side. Now on the right-hand side, what you're going to do is again write 1 with write the unit that's to the left. So in this case, actually that wasn't supposed to be a gram. Let me fix that real quick before I move on. So that was supposed to be a meter. Okay. Now over here, what I'm going to do is basically take the number that's below the unit, and I'm going to make that a positive, and I'm going to put that on the unit to the left. So I'm going to say 1, 0 for nano is 10 to the negative 9th. So I'm going to say positive 9th meter is equal to, this time I put 1 on the right-hand side, and I put nanometer there. Okay. So this converts, for instance, from meters to nanometers. Now I have an equivalent statement for that as well. So everybody sees how I did that. I changed the exponent that's below the prefix to a positive and put it with the with the unit that's to the left. You could decide just on the right-hand side to put the number with the unit to the right, and that would work as well. If you did that, you'd get 1 meter is equal to 10 to the negative ninth nanometers. But notice that doesn't work out, right? 10 to the negative ninth nanometers doesn't work that way. That's the problem with it, and that's why I had to make up that other way of doing it. But if you say, hey, wait a second, I'm on the right-hand side, so maybe I should take the first digit to be the rightmost unit, in which case I'd say 1, oops, in which case I'd say 1 nanometer, or in this case, let me write what I just erased. I'm going to say 1 nanometer is equal to 10 to the negative 9 grams. That's another way you could work as well. Okay. So let me show you how I'm going to convert this. So for instance, I have 1.234 times 10 to the negative 13th terameters. I want to convert that to nanometers. So the way I'm going to do it is I'm going to write 1.234 times 10 to the negative 13 terameters. And because I know I'm working with fractions and I've been teaching for 30 years, I've learned that my gifted students, when I'm teaching calculus-based physics, 241, 242, you guys are all classified to us at TCC as gifted students. So take that for the compliment it is. What we mean by that is a very small fraction of students that get to go to community college ever are able to pass Calc 1. Those students we call normal students. And therefore, those students that can pass Calculus 1, especially the ones that make A's and B's in it, they're special students or gifted students, okay? So what I've decided over years of teaching is even though you guys are my gifted students, you often come here, or some of you come here with a not a very good understanding of how to add, subtract, multiply, and divide fractions. Okay. So in an effort to help you with that, what I'm going to tell you is whenever you convert units, go ahead and make it the number into a fraction. So like in this case, I'm just going to write it over 1 because you can always write any number, including denominate numbers, over 1. If you had a unit like, 60 miles per hour, what you could do in that case is you could write 60 miles divided by 1 hour, and that would work as well. Okay, but definitely do that because then it makes it a little easier to know what to do when you do the unit conversion. So I'm not going to take off, obviously, if you don't do it. I'm just telling you this is what the best practices I've learned have been. So I'm first off going to use my equivalent statement that I just put an asterisk on right now. Okay. Now, should I do that with the terameter in the numerator or the terameter in the denominator? Anybody know?
Denominator.
Exactly. And the reason we did that is twofold. If I put the terameter in the bottom, then I know what's going to happen is the terameter here cancels out the terameter here. And that's specifically because the number is being multiplied by terameters. And this number down here is also being multiplied by terameters. And this right here is multiplication as well. If that's not all multiplication, you can't do this cancellation. Okay. So I look up and my equivalent statement says that the terameter is associated with the number 1 and the meter is associated with 10 to the 12th meters. So if you look now, the terameter's been canceled out and I have basically the ability to report the number in meters, but that's not what I want. I want nanometers. So I'm going to put another multiplication symbol and expect another fraction. So now I have an equivalent statement that I can use either this version or this version, which are really the same thing in some sense. Whoa, except for, again, I wrote a G there instead of a M. I don't know what's wrong with me. So you can use those as well. In this case, should the nanometer go in the top or the bottom?
The top.
The top. So that's the other reason that I didn't actually expressly give you, even though I hinted at it in the last part. The other reason that I had to put terameter in the bottom is because that would make the meter in the top, and that's ultimately the unit that I want to change is the top unit. So in this case, now I'm going to put the meter in the bottom, and as you said, I'm going to put the nanometer in the top. The nanometer was associated with the number 1, and the meter was associated with the number 10 to the 9th. Whoa, nearly. 10 to the 9th meters equals 1. Wow, what the heck did I write there? 10 to the, that was supposed to be 10 to the positive 9th meters equals, no, that's not right at all. I don't know. Hopefully I said it differently when I was covering it, but I clearly wrote it down wrong. Clearly, there's not a billion meters in a nanometer. A nanometer is like 10 times bigger than an atom. So whatever that was, that's crap. But I'm going to say 1 nanometer goes with the number 1, and 10 to the negative 9 goes with the number nanometers. So maybe that's a better way of looking at it. But 10 to the negative 9 goes right here. And by the way, 10 to the negative 9 is the same thing as scientific notation 1 times 10 to the negative 9. And 10 to the 12 is the same thing as scientific notation 1 times 10 to the 12. Now, notice something else I do here. I canceled out the terameter with a slash that went from the top right to the bottom left. I'm going to use a different symbol for the meters canceling out. And in fact, I'm going to go from top left to bottom right. I've discovered in my own years of being a student and then a teacher that this way allows me to quickly error and analyze. So if I find a mistake later, I can quickly verify whether I canceled out the right units, because each unit will be canceled out with a symbol that matches the other symbol. So if later I look and see that I canceled out a meter with a kilometer, I'll know that that's where my error came from. So that's why I'm using a different symbol each time. So I'll do a slash from top right to bottom left, then I'll do a slash from top left to bottom right, then I'll do both of them, which is an X, then I'll do maybe a curly one from top left to bottom right, then a curly one from bottom left to top right, and then an X with both of the curly ones. And I keep doing like that, little weird things. You'll see an example in a second. But now what you can see is all the units are canceled out except for nanometers. So we know it's right. Now, here's the trick, and this is what I'm doing in case you happen to be a little rusty on your fractions. It's not that there's anything wrong with you. It's mostly a matter of when you were in grade school, somewhere along middle school, maybe even elementary, but definitely by high school, they knew that they had to get you guys up to speed with working with electronic computers and stuff like that. Most school systems could not afford computers for everybody, but they could afford, TI 80s and stuff like that. So they ended up buying scientific calculators and let that fill the bill. Well, that meant they started giving middle school and maybe in some cases elementary school, but definitely high school kids had access to scientific calculators. So the kids never, ever, ever did any fractions anymore because they didn't have to, right? Well, that has a consequence. The consequence is that you forget how to work with fractions. So just be okay. If you know your fractions, you can do it any way you want. What I'm going to tell you is in the case that you don't know your fractions, this is how you do it. So in not knowing your fractions, when you do a conversion like this, what I'm going to tell you is the best thing to do is multiply all the numerators. So I'm going to take the numerator that is 1.234 times 10 to the negative 13. I'm going to multiply that by 1 times 10 to the 12. And then I'm going to multiply that times 1. And I've now multiplied all the numerators. That will make my new numerator, and my new numerator is 0.1234. And notice the numerator actually has a unit of nanometers. So I'm going to write that up there. Now I write a fraction bar, and now I'm going to multiply all the denominators. times each other. I'm going to say 1 times 1 times 10 to the negative 9. That gives me 10 to the negative 9, and it doesn't have any units. So now all I have to do is take the new numerator and divide it by the new denominator, and that'll give me my answer. So I'm going to take 0.1234 and divide it by 10 to the negative 9th, which is the same thing as multiplying by 10 to the positive 9th. So I'm going to say divided by 1 e to the negative 9, and that gives me 1, 2, 3, 4, 0.00000 nanometers. And of course, in scientific notation, that is 1.234 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Whoa, Nettie, is that right? It should be 8 or 9. 1, 2, 3. What do I have? 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 10 to the 8th is what I got there. And this should be nanometers. So I might have made a mistake when I wrote 10 to the positive 9 over there. Did anybody find a different figure? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ah, that's why. Okay. This actually was supposed to be 10 to the negative 12, not 10 to the negative 13. So if I do that, what I'm going to do here is I'll say this answer is supposed to be negative 12. And then I'm going to go down here and say this answer is supposed to be negative 12. And then this answer is going to be a little bit bigger. So I have to put the decimal right here and cancel that out. Then that's going to give me 10 to the negative 9th. So I'll cancel this out and just make it 9. And this should also be 1, 2, 3, 4, 5, 6, 7, 8. Oh, I need another value of 0 in there. So that fixes all that. Feel free to go back and work it over, okay? But that was what happened with that error is when I counted, I miscounted up in the top. So that's what I made those purple marks to just show you what it was supposed to be. Does everybody understand the process, though, of converting units? Does that make sense? So let me show you another one. This one, I can't believe that. I just had a brain fart. I'm used to books, so I started taking my iPad and turning it over so I could write on the back of the page. I might be having a stroke. I'm not sure. Anyways, so let's go on. We only got about 8 more minutes. I'm going to show you something a little more complicated. Let's convert 60 miles per hour. So I'm going to write this as 60.0000 miles per 1 hour. Now I'm going to use sort of the best way to do this is using things that I happen to know off the top of my head that are exact conversions. So I'm just going to run them off, and hopefully you'll remember them as I say them. So first off, I'm going to convert miles to feet because I know that 1 mile is equal to 5,280 feet. Okay. That gives me miles canceling out with miles. Now I'm going to say 1 foot is equal to 12 inches. Now that's going to allow me to say that the foot cancels out with the foot. You can see that I'm canceling out with a different slash each time. Now I can go from inches into the metric system by using the conversion between centimeters and inches, which is another exact conversion, and that is that 1 inch is equal to 2.54 centimeters exactly. So in this case, I'm doing inches by Xing them out. And you see now I've used 3 different versions of crossing stuff out, and I've gotten to centimeters per hour. I want meters per second. So now I'm going to say, okay, well, I know that there are 100 centimeters in 1 meter. So now I'm going to use a swishy slash like that and a swishy slash like that. Now I've got meters. Okay, so the numerator's now in the units that I want. The denominator I want to be in seconds, so I got to start working on that. Notice the denominator has a unit that's in the bottom, so to cancel that unit out, I have to put the same unit in the top. I could go straight from hours to seconds, but I want to show you the 2-step process. So I'm going to say 1 hour is equal to 60 minutes. And now I'm going to use a different symbol. I'm going to go slash again, a curvy slash from lower left to top right. So this, this hour is going to cancel out with this hour like that. Now I'm going to do another conversion where I'm going to say 1 minute is equal to 60 seconds like that. And now I'm going to use another slash. This time I'm going to do slash from top left to bottom right, which I already did. I did bottom left to top right, which I already did. So now I got to do the X one, which is going to be like this and like that. And like this and like that. So you can see I managed to find a different slash every time. My next one would have been a straight line with a circle on the end or something. Okay. So now all I have to do is, like I told you before, multiply all the numerators to get a new numerator. So I'm going to do 60 times 5280 times 12 times 2.54 times 1 times 1. And that gives me 656,064. And the unit on the top that survived was the meter, so that's my new numerator. My new denominator is 1 times 1 times 1 times 1 times 100 times 60 times 60. That gives me 360,000. So I'm going to write 360,000, and the only unit that survives on the bottom is the second. So now I'm going to take 9656064 divided by, oh crap, I went to type 0 and actually typed a decimal point instead. So now I'm going to say divided by 360,000, and that gives me 26.8224. And that's meters per second. So that's the actual right answer. And notice however many sig figs you put in is how many you get out, because all those conversions were to an infinite number of decimal places. Now, there's one more conversion I really need to show you guys. I'm going to say that the density of water is 1,000 kilograms per cubic meter, and I'm going to try to convert that to grams per cubic centimeter. So this is the way I do it. I say, first, let's tackle the kilograms to grams. I know that 1 kilogram is in fact equal to 1,000 grams. I can get that from the mnemonic I taught you earlier. So that's one thing that could happen. I've now got the grams. The other thing I need to do is change the meters cubed, which means meter times meter times meter, to centimeters cubed. So now I'm going to use 1 meter equals 100 centimeters, but in that case, that only handles one of them. So I got to do it again. Well, now I've only handled two of them. I've got three total, so I've got to do again 1 meter, 100 centimeters. Okay. Now, in this case, what happened is the meters cubed cancels out with this guy, and this guy. And now I've got grams per cubic meter. The new numerator is 1,000 times 1,000, which is 1 million grams, divided by 100 times 100 times 100, which is also 1 million. Okay. So it turns out that the density of water is 1 gram per cubic centimeter. I will also tell you that 1 liter is defined by, basically think of a cube like so. And this cube is 10 centimeters by 10 centimeters by 10 centimeters. And can anybody tell me what the volume of that is in cubic centimeters?
Yeah, 1,000.
Yes, it should be 1,000 cubic centimeters. Okay. Now, class is technically over. If anybody needs to leave, I know y'all's lab was canceled tonight. So if you could allow me maybe 10 or 15 minutes, I can help you a lot better. But you're free to go. The video is going to be recording. Even if all y'all leave, I'm going to finish this up. I've got 2 more things I want to show you. So you're welcome to split. That's not going to be anything held against you or anything. If you got to go fix supper or got to go pick up a child, do that. But I'm just going to finish this out. Now, if I divide both sides of this expression by 1,000, what is 1 liter divided by 1,000? Let's not use a number. Let's use one of our SI prefixes. So what is 1 liter divided by 1,000?
Point 0.001.
Yes, that's exactly right. 0.001. But do we have an SI prefix that corresponds to 1 over 1,000?
Is a milliliter?
Exactly. So this is actually equal to 1 milliliter. But what is 1,000 divided by 1,000?
One.
It's 1, and that's 1 cubic centimeter. So what we've just learned is that 1 milliliter is exactly equal to 1 cubic centimeter. That's something you're going to learn if you have kids, or if you babysit kids. There's a good chance that a child will get sick and your doctor's going to write a prescription for 5 cc's of amoxicillin every 3 hours or every 6 hours or something like that. And you take it to the pharmacist and you get it filled, and the pharmacist is going to say, I want you to apply 5 milliliters, allow the child to drink 5 milliliters of this every 6 hours. And you're going to like, oh man, this is different from what the prescription said. Well, that's why a milliliter is the same thing as a cubic centimeter. So for extra credit, the density of water is 1,000 kilograms per cubic meter. And an estimate for the density of seawater or salt water is 1,025 kilograms per cubic meter. So for extra credit, you can convert this to pounds per cubic inch. You can convert this to pounds per gallon. You can convert this to, let's say, pounds per square inch times feet. You can also convert it to pounds per foot squared times foot. Actually, let's scratch that one. I don't need that one. I'm gonna kill it. But you can also convert it to ounces per fluid ounce. So an ounce, like the one in the top, is a 16th of a pound, whereas a fluid ounce is a unit of volume. So you can do that for extra credit. And what you do is you write it up handwritten and you work out the conversions for both of those, the seawater is regular as well as the regular water. And then you take a photograph of it, convert that photograph from a JPEG to a PDF and turn that in. I use something called Fast Scanner. I think it's called Fast Scanner Pro or Fast Scanner something. Let me see what it is real quick. I use Fast Scanner Plus. That's it. And I used it so much I went ahead and paid the whole $1.99 to get the full version. But anyways, y'all can do this for extra credit. There will be a place in week 1 module for you to turn in that PDF. And if you get it 70% right or better, I'm going to go ahead and change that grade to 100. And everybody else will get a 0 for not doing it, but I'll up the number of drop grades by 1. All right, so that's the vast majority of really what I wanted to do. There's 2 other things I really wanted to try to cover today, so I'm going to cover them in this video. Again, you guys are free to leave if you need be. I will do it in the quickest way possible, but you are free to go, so don't feel bad if you have to. One of them is what we call unit analysis or dimensional analysis. So there's a way where you can assume something like, assuming force depends on mass and acceleration, what must be the form of the function? Now, if I gave you this question, you're not far enough along in physics to know some of this stuff. So I have to give you this information. For instance, when I write F for force, but I put it in square brackets, that means what I want is the actual units or dimensions. The dimensions for the unit of force is the capital M for mass, the capital L for length, and the capital T squared in the bottom for time. It's time squared. So I have to tell you that because you don't know that yet. The dimension for mass would be just plain M, and the dimension for acceleration would be L over T squared. Now, that's dimensional analysis. If you wanted to do unit analysis, then that F would be kilogram meters per second squared. So just as a side, I'll write this as kilograms meters per second squared. This would just be kilograms, and this would be meters per second squared like that, which is also the same thing as meters per second, which is the way I'd prefer you to say it. Okay. So how do I find out the form? Well, what I'm going to do is I'm going to say F is equal to M to some power P times A to some power Q. You can't add mass and acceleration because they have the different units. You also can't subtract them. So all you can really do is raise M to some power and raise A to some power and either multiply or divide those quantities. So that's the way I handle that. Now, in so doing, what I do is I say, well, the units or the dimensions have to match. So I'm going to say the dimensions of F has got to be the dimensions of P times the dimensions of A to the Q power. So now all I have to do is say this is ML over T squared is equal to m to the p power times L over t squared to the q power. I can rewrite that as m to the 1, L to the 1, and notice I can write that as t to the -2 because the negative tells you it was in the denominator. Does that make sense? Now, the right-hand side is going to be m to the p power for obvious reasons. The other one's a little more complicated. It's going to be L to the q power, but it's going to be t to the -2q power because when you raise a power to a power, you multiply the powers. Does that make sense? So now I just take each particular dimension and I say for m, I've got 1 on the left side for the exponent, but on the right-hand side, I've got p. So I know p has to be equal to 1, but that's not necessarily sufficient. That's just necessary. Now I'll do the L, and I know L on the left-hand side is 1, and on the right-hand side, it's Q. So I know Q has to be 1. That is necessary, but not necessarily sufficient again. So finally, I also have to do time. And on the left-hand side, time is -2, has an exponent of -2. But on the right-hand side, it has an exponent of -2q. So if I divide both sides by -2, I get 1 is equal to q, which is the same thing we already learned. So that tells me, yes, all three of these are consistent, so it works. And what I would say is my equation is F equals ma, which happens to be Newton's second law. Now, if it had a number like pi or 1/2 or 3/4 or the square root of 2 in front of it, I wouldn't know. But I still have roughly a form, so I could just do an experiment and, varying a or something like that, and then ultimately figure out if there is a number in front of it. In this case, we got exactly the right number. Everybody see how you do that? Let me give you a skeleton of another one. Let's say E is a function of m and the speed of light c. I bet y'all know what equation this is. Okay, so what that means is I'm going to treat m as if it's raised to the p power, and I'm going to treat c as if it's raised to the, well, I said c power, but that's stupid. I'm going to raise it to the q power. Okay, then I have to know that the dimension for energy is not unlike force. It's literally just a little bit different. It's going to be mL squared over t squared. The dimension for m, of course, we already know that. The dimension for m is big M, and the dimension for the speed of light is the same thing as the dimensions for velocity. So that would be L over T. So I can say m L squared over T squared is equal to m to the P power and L over T to the Q power. And I can make that a little easier by calling this m to the 1 power, L to the 2 power, T to the -2 power is equal to m to the P power, L to the Q power, and T to the -Q power. Now all you have to do is carry out the rest, and lo and behold, you'll get the right answer. So that's just a skeleton of an example, so you'd have more than one. All right. Now, the last thing I want you guys to be able to do is estimate, do what we call those Enrico Fermi or Fermi calculations. So I'm looking right here in this room that I'm in, and it looks like my room is roughly about 10 feet that way, which I'd call maybe 3 meters. And it looks like it's about 3 meters this way. And my ceilings are bigger than 8 foot. So I'm thinking they're probably about 3 meters as well. If there's any ambiguity in that, what you could do is say, well, I know it's not 1 meter, and I know it's not 10 meters. I know it's bigger than 1 meter, but I also know it's smaller than 10 meters. So I can take the geometric mean of 1 meter and 10 meter, which means 1 meter times 10 meter equals 10 square meters. And then you take the square root of that, and the square root of 10 is really close to pi. So you'd say that's 3.14 meters. That's the way you could do it if you weren't really sure roughly what it is. You could take what you know it's smaller than, what you know it's bigger than, and then multiply them, take the square root, and that would be the geometric mean. But what I want to figure out is how many fruit flies could fit in my room. So in doing that, I'm going to say my room is 3 meters by 3 meters by 3 meters, which equals 27 cubic meters. I'm going to say a fruit fly is about 1 centimeter by, I'm going to say the dimension in and out of the page is about 0.5 centimeters, and the dimension vertically is about 0.5 centimeter. So the volume of a fruit fly is equal to 0.25 cubic centimeters, which I can say 100 centimeters is equal to 1 meter, and then cube that. And basically, I'm going to get 0.25. Let me turn my calculator on. Divided by 1 million. Gives me 2.5 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. So this is 2.5 times 10 to the negative 7th cube meters. So the number of fruit flies I could fit in my room is equal to the volume of the room divided by the volume of the fruit fly. So I'll take 27 and divide that by 2.5, or actually I'm just going to divide that by the answer, which I already did. So I'm going to say second function. Where's my answer button? Where's my answer button? Okay, I can't do the answer button. So I'm going to say 0.0000025, and this gives me 1.08 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th flies, fruit flies. So that's a typical estimating problem that you should be able to do. You guys need to get used to looking at distances and estimating how big they are in meters. You can try it in feet and then convert it to meters. That'll be fine, or convert it to centimeters. That'll be fine. But you need to be able to do it. What this tells me is I can fit about 100 million fruit flies in this room. Okay. And that's it. That's enough of chapter 1. I have set the deadline back, so y'all have until Wednesday to do it. You guys are free to go. Hopefully you've already texted or chatted me your first and last name. If you hadn't, please do. You're free to go. I did keep you an extra 18 minutes. Thank you guys that stayed. I appreciate that. I shouldn't have to have that problem again, but at least I was able to answer those questions at the beginning and then do this. So feel free, if you have any questions, you can take photographs of the actual problems you're trying to do with the multiple choice answers, and you can send them to me in a text or an email, and I will help you as soon as I see your message and let you know. But y'all have a good weekend. Stay safe and let me know if you need anything.
Hey, Professor, did you say the video gets posted?
Yeah, I'll be posting it probably within an hour.
Do you know where it would be
Yeah,
posted, like in a mod?
yeah, it's going to be on my YouTube channel. Let me stop sharing this
Oh,
and I'll type that in for you guys. Here it is in the chats. It's www.youtube.com/Billy Billy Younger Younger Physics PHYSICS Solutions, like that. So you can go to that site and you can see, for instance, the video that I did Monday's already been posted, and the video that I did Tuesday's already been posted. Now you'll see this one, like I said, at least within an hour.
okay, great. Thank you so much.
No problem. Have a good one, Alec.
You
Giovanni
too.
or Tracy, do you have any questions?
Yeah, I have a question.
Go for it.
So when you buy the Pearson textbook, does the MyLab and Mastering come with it, or is that a separate purchase?
Most bookstores, if you buy a brand new book, it will automatically come with the access to it. If you buy a used book, that's not necessarily the case, but a lot of places have decided, hey, I'm going to take a used book and re-shrink wrap it with the access and then sell it at a higher price than you'd normally sell a used book. So it all depends on where you're buying it. You just need to make sure the seller tells you whether or not it comes with a valid access to Pearson.
So let me just tell you my situation. So I did buy a whole new book, the fifth edition one. And
It is fifth
so,
edition, right?
yeah, every time I click the Access Pearson and Open Pearson, I have like two yellow bars that say Open MyLab and Mastering. And so when I click that on the left, there's sort of like a tab to put an access code,
Mm-hmm.
and on the right there's like
Free trial.
no, that's at the bottom, and on the
Okay.
right is to pay for it. Like
Okay.
the person earlier said, one is 150 and the other is 85.
Right.
And so, I mean, I did get an access code when I bought the book, but I don't know if I made a mistake because the way I entered the access code was through, so the school I'm with ESCC, and so we use Brightwave, I think, for
Mhm.
Brightwave or Bright Shell, something like that.
Yeah.
So that's where I put the access code, but now when I try to access it through Canvas, when I use that same access code, it tells me that it's invalid. So I don't know if I sort of messed up by using the access code on a different sort of website.
You probably did, but there might be something I can do to help you with that.
Mm-hmm.
Please send me an email. Take a picture of your access code and include that picture and tell me your full name and tell me that full story in the email. And
Okay.
I'm going to send it to my Pearson rep, and I suspect she can either get you a brand new code or make that one valid again.
Okay, because or I guess just to make sure if it's the same, do you know how many characters the access code has to be?
It's normally like 12 or something big like that, 12 or 16.
Yeah, because I think the one that I got was it is let me see. It's four, one, two, three, four, five. It's 24 characters, four for each box.
Okay, yeah, that sounds about
And
right.
so yeah. And so I don't know if I just like sort of invalidated my own by using it on a different website to because I can access the textbook. I do have access to it, but I just don't have access to
Yeah,
the my mastering and lab.
gotcha. Yeah, that might be such a problem since you've already accessed that one. Uh, you access the book through the other portal. That
Yeah.
might be something that they kick back on, but I'll still send it and tell them exactly what happened. And they might be able to make that one no longer valid so that you won't be able to access it that old way, but you can then use it on this other one. But I suspect what's going to happen is they'll probably make that one invalid and give you a brand new one. And then you put that in the appropriate place through Canvas.
Okay, yeah, because I haven't been able to do any of the assignments yet, which is it's a
That's
bit.
not good. Yeah. So I've at least given you till Wednesday. If you send me that email tonight or tomorrow, I'll send that immediately to my sales rep, and she usually gets back to me within the same day, if not the very next day. So hopefully she'll be able to. What you could do in the intervening time is try to use the free access.
Mhm.
That's supposed to allow you free access, I think, till like September 9th.
Yeah.
So you might try that for a while, but if you've already put anything in on the Canvas side, then it's not going to work. But go ahead and send me that email with the picture of your access code so I can actually read it and turn it into them, and just tell them exactly what happened, your first and last name, that you're at another college. You thought you had to put it in here, but you ended up putting it in there instead. And I will turn that over and see what I can get you.
Okay. All right. Thank you.
No problem. If you're not able to get to the work by the due date, just send me an email when you finally finish it, and I'll give you your points back for if it's late.
Okay. All
Okay.
right. Thank you.
Good luck, Giovanni. Sorry about that, bud.
Yeah. You have a good day and good night.
You too. Thank you. It looked like Tracy had a question about why Pearson is giving me an error. I will tell you that that sometimes happens because you have a pop-up blocker. So Pearson creates new tabs, and if your pop-up blocker is on, it's going to stop that and read it as an error. Sometimes it requires you to empty your cache. So you might want to try that with the browser you're using, empty the cache, and then go back and try it again. Other than that, what you need to do is contact Pearson and find out from them. Make sure you're not using Safari. I know we've never had any good luck with Safari, and whatever that Microsoft version of the browser is, I think it's Microsoft Edge or something. That's crap. Don't use it. It at least does not work very well for Pearson. So I would not use it for Pearson. I would use either Chrome or Firefox, and I wouldn't use Safari either. But if you use one of those two, that can usually remedy it. Once all that's done and nothing's still working, that's when you want to go ahead and call Pearson again. So hopefully you got that message, Tracy. And bye, everybody. Homer says bye. See you, folks.